the live.
Good afternoon, everybody. First, I would like to thank the organizers for inviting me to this hack, and I would like to speak about some facts about formal concept analysis. Formal concept analysis is a data mining method, special, based on some algebraic properties, and it is based or found by Ganter and Wille, German mathematicians, in this textbook. So what is a principle? We have formal context. It is a triple ABI. What is A? A is a set of attributes or columns, and B is the objects, rows, and I is incident matrix. It means it is something like that, some database table. It means that attributes are columns of this table, objects are rows of this table, and some of the fields are filled by, in this case, by hearts. It means by ones, and or by zeros, the empty fields. Yes, zeros and ones, two values. This is a basic for formal concept analysis. So in our example, we have the set A is a sports, and B is a set of people. We have 5 boys, and they like or doesn't like, or play or doesn't play some sports. So we can see that I is a subset of A times B. It means it is a set of some pairs. For example, this first heart is hockey Fero. The second is a hockey Jano, and so on. We have 10 tuples in this set I. Okay. So it is our example, and what is Galois connection? We have 2 antitonic or adjoint mappings. The first one, it is denoted by the up arrow, is from our set of B. It means a set of all subsets of the set B. In our case, it is a set or groups, all groups of our boys. We have 5 boys. It means that we have 2 to 5. It means 32 different groups of them. And PA is a power set of sports. Again, we have in our example 2 to 5. It means 32 groups of sports. So it means that this mapping, the up arrow, is mapped from the set of boys to set of sports. It is defined by this formula. It means that if we have some set of boys, a group of boys, then we map it to the set of sports, such sports which are common for these boys. Yes, it means X up arrow are the attributes common to all objects from X. In our example, we have Fero and Jano, and we can see that the common sports are hockey and frisbee. Volleyball is only for Fero, not for Jano, so it means that volleyball is not common. And it means that Fero and Jano up arrow is hockey and frisbee. So it is written here, hockey and frisbee. Okay. Then we have, because we have 2 mappings, the second mappings is down arrow. It is from PA to PB. It means it is defined for each group of attributes, and the values are groups of boys. It means that it is a opposite direction to these mappings. Yes, it means that they are antitonics. And the definition is very, very similar formally. Y down arrow means that we have all, it is written here, all objects having all attributes from Y. Yes, for example, football, basketball. So we can see our table, football and basketball, and we can see that Duro and Misho have these sports or like these sports. So it means that football, basketball, down arrow is Duro and Misho. So it is important, not only in our example, but generally, these two mappings form a Galois connection. What is Galois connection? It is the conglomerate of these four properties. The first property means that if we have two groups of objects, it is x1 is subset of x2, then x1 arrow is superset of x2 arrow. It means that this arrow, up arrow, reverts ordering of these groups. This is a group of boys in our example, and this is a group of sports. And it's a natural, if you have more boys, then there are small group of common sports of them. The second is similar. We have two groups of sports. The first is subset of second, and then down arrow again reverts this ordering in the similar reason. The second says that for each subset of boys in our example, subset of objects, these two application of arrows, the first one is up arrow and the second is down arrow, and this result is superset of original set. Yes, it means that if we apply these two mappings, then our result will be the same or greater than original. And the symmetrically it holds for attributes. Okay, so what are concepts? We can see in this that if the first arrow is from PB to PA, and the second is from PA to PB, we can compose them. Yes, composition of up arrow and down arrow is from PB to PB. Yes, it means from PB to PB. This means that this is a first application, this is a second application, chronologically. So, for example, what is CL? It means closure for ferro. Okay, again, we can see our table, and we have ferro. It means hockey and frisbee. Okay. Sorry for this clicking. Ferro, hockey and frisbee, and again hockey frisbee, down arrow. Again we can see hockey and frisbee. It means ferro and piano. It is a result. So we have ferro and piano. Start was ferro and the goal was ferro and piano. And another example, if we start from ferro and piano, again we obtain hockey and frisbee, and again we obtain ferro and piano. We can see that in the first example, the original is not equal to end, and in the second example, the start is equal to end. It's very important for this method. CL is a closure operator. It means it has these three properties. The first one, that if we have two subsets of objects, then after application the CL function, we obtain again a subset of B, and in the same ordering. Yes, because the first arrow reverts and the second reverse again. So In the result, we have the same ordering. The second, that each set is a subset of its closure. It's natural. And the second, it means that it is enough to apply closure only one time. So if we have result CLX, then it is not needed to apply CL again because we obtain the same result. Okay, so what is concept? Yes, it's a concept, formal concept analysis. What is a concept? Concept is the pair X and Y. X is the subset of B and Y is subset of A. It means this is a pair of subsets of boys or subset or of sports, but such that if we apply arrow to X, we obtain Y, and again if we apply arrow for Y, we obtain X. X is extent, Y is named intent. For example, ferro-Jano and hockey frisbee is a concept. Yes, we can see this. But ferro hockey frisbee is not concept. Yes, it means that X is an extent only if cell X is equal to X. Yes. So it means that extent and intents are exactly those sets which can be defined by so-called red Indian names. For example, Janos Sports, or those who play hockey and frisbee. Yes, these subsets of sports or boys which can be defined by these Indian names, there are extent or intents. Okay, concept lattice, it means that we have two concepts. We can order them by this way. It means that we can see xy is subset of x2, but y1 is superset of y2. So this is a picture of our example, or our concept of our example, and we can see that we have 2 to 5, as I said, groups of boys, but only 6 of them are concepts or extents of concepts. Yeah, this is for the 6 points. This is a concept. So this picture is so-called concept lattice. It can be proved that this lattice in the algebraic meaning. So, okay, so this was something given by original Gunter and Wille book. But what about the such data? We have not only two values, 1 and zeros. We have some, for example, decimal numbers, 0.8, 0.1, and so on. Yes, so we have many data. It means, for example, that Duro is perfect in English, but not very good in math. And Micho is not very good in English, but rather good in physics, and so on. So these numbers may mean that how some boy is good in this subject in school. So this y is not a relation. This is not subset of Cartesian product, but this is a function from product to 0, 1. And again, it is a Galois connection, but we can redefine this these arrows. This is a first. For example, upper arrow is defined for attribute, for example, for subject, that we can see that we can take infimum of values in this column, but only these values which are for objects from X. For example, Jano and Micho, it means third and fourth rows. So we ignore other rows, and we see only this first, the third and fourth rows. So we can see that English is infimum from 0.2 and 0.4, it means 0.2. So this is the result. Again, physics, minimum of these two values is 0.3, and so on. Maths 0.1, Slovak 0.2, and sport 0.3. These are minimas from these two rows. Upper arrow or up or down arrow, that we have some prescription, so it means some condition. For example, English must have to know to the grade 0.2 and so on. And we can see that Duro fulfills this prescription because it's better in English than 0.2. This is he is better in physics than 0.3 and so on. So it means that Duro will be in the result. But Fero's English is better than 0.2, but physics is worse than 0.3. It means that Fero will be not in this result. Jano, okay, we can control it. Misho, Palo, and so on. It means that if we have some function from FA to PB, then we obtain the result from PB. FA means fuzzy function from A. Yes, it is a function which domain are exactly these attributes A, and values are from 0, 1. It means fuzzy values. So again, as I say, it is a closure operator, and we obtain. So we can repeat this procedure, but for this table and these two mappings, and we obtain again concept lattice. It can be proved that this is a concept lattice always. We can see again over point we have group of boys, and after and below these points we have fuzzy functions. These blue things mean that where are objects or concepts, where are these boys, where are these boys. Okay, so it was some theory, basic theory and fuzzy theory, or some fuzzy theories, and we now can show application to a social network. So application of this method to a social network. So it is good only for small social networks. So we did some experiment in some secondary grammar school with some class, about 12 years old children, 33 pupils, yes, in Alewa in Kosice. Goal of our experiment was to identify groups of friends. And our idea was the Slovak proverb, Vranak vrane sada, it means birds of feather flock together. It means that friends are similar, it's our hypothesis. It means they will be rated by schoolmates similarly. This is a basic idea behind this experiment. So it means that each schoolmate from this class evaluated the his or her schoolmates by these seven values. 3 mean very good friend. 2 means not so good friend but good. 1 is some sympathy for her or for him. 0 is neutral, and so on. So we have 7 linearly ordered values. This is a Likert scale, seven values, and we obtain such table. It means that school teacher or class teacher of this class picked all this data from these boys B or girls G, and we obtain such table. we can see some 0, 3, or -3, and so on. Of course, this is not fuzzy values because they are not from 0, 1. So we should transformate these values to 0, 1, some equidistant transformation, and then we applied one-sided fuzzified FCA. But the output was not so good. We obtained 1,000 concepts. It is not very good because how to interpret such result? So it is not possible for school teacher or for class teacher to interpret this such amount of concepts. So it means that we need some reduction of these numbers. So we use, or we applied this very well-known quotation of George Orwell from Animal Farm, that all animals, in our case, all extents are equal, but some extents are more equal than others. So it means that we must take these 1,000 concepts and take some of them which are better than other. It means we use some metrics on these extents. It means this row is some function which have 2 inputs, and these inputs are extents, and the result is some number from non-negative number. And then we applied such algorithm. It means that this cluster or these extents which are very close, then we join them to bigger cluster. And then you can see that this algorithm is not very complicated, and it is rather easy to implement. It's no problem. Of course, this algorithm is theoretically exponential, but practically is paradox linear. The result is about 2 big concepts. It means that we have 34 or 30 pupils in the class. So this result will have 70 concepts. It is not so much, so that we can interpret them. So this is a diagram of results of the experiments. So we can see each point is a cluster or extent. We haven't 3 biggest clusters because this picture will not be readable then. But we can see interesting things. These pink clusters are girls group, and these blue clusters are boys group. And we can see rather strict division by gender. It means except this girls 11, you can see that this girls 11 is very boyish. It's a karate kid, and we can see that the friendship is more than boys than the girls. Yes, girls are one group, but this girl 11 is in the group of boys. The second observation, G10. For example, this is this point. We can see that this cluster obtain or have more boys, or all boys, or almost all boys, and one girl, this G10. And then we can by asking this expert or class teacher says that this is a class beauty. This is a girl which is very popular for almost all boys. B15 is this boy in the in the left, in the right side. So it is isolated because it's a class exhibitionist, which was not liked by the schoolmates. Another result is we have these three boys in the right, which are isolated too, the small group, which are not friends with the rest, because, and it is again assertion of our expert, it means class teacher, which says that these boys are underestimated by others because they have bad achievement and bad social status. And the last observation is that we have pairs of seatmates. Yes, for example, this 13 boy 14 and boy 21 sit or sat in the one desk and so on. So we can see that this application is of formal concept analysis with should be combined by some other method. It means this Rice-Siff algorithm, and then it is able to uncover some hidden relationship between this group of people, pupil. So, what are our future plans? This situation was only in 1 year, but we can repeat this experiment in the same class for example 4 or 8 years, and we can see some changes in time. It means we can look for evolution of relationships in this class. The second application, our plan of application of formal concept analysis is didactics of mathematics or didactics of informatics or computer science, if you want. Task versus goals. It means task will be objects and goals will be attributes, and then as a result we hope we obtain some generalization of graded task system, because graded task system is a linear ordering of task which is used in didactics, but by this method we obtain not linear system, not linear system, but this concept lattice. Another application didactics, the pupils versus approaches. It means that we have some hard task, for example, from mathematical Olympiad, and we have different solution of this task by different pupils, and then this formal concept analysis or concept lattice can show us in some sense originality of the solution. Then it means that it is a good candidate for measurement of task complexity and originality. And the last, our plan is looking for trendsetter. What does it mean? This is again based on the Latin phrase quod licet Iovi non licet bovi. It means we have this table 0, 1 or this fuzzy table, and if some value in some field is changed, it can cause the change in concept lattice or do not. And it means that if some change in some field causes the change of concept lattice, it means that this field, this object, is in some sense trendsetter. Yes, but if not, it means if some change his or her behavior, then this behavior will have not influence to this concept lattice. Yes. So I think that is all what I want to say. So thanks for your attention.